right, here we go. I am Mr. Bishop, the guy holding up the pointer finger and pointing to this Bitmoji. We are on Chapter 2, Day 5. We're talking about applications of that RREF command we learned about in the last video. So if you're not sure how to do the RREF command in your calculator, go back and watch that last video. There's a calculator demo there because we'll need to use it to solve some of the real life scenarios in this video. Okay, let's refresh our memory about a couple things from the last video. One, we know RREF stands for Reduced Row Echelon Form. And if we're solving three equations, let's say with x, y, z, the RREF matrix would look something like this, right? We might say it has ones across the diagonal, right? And then zeros above and below the ones. And then we'll still have some constant terms here in the answer column, which allows us to read off our solutions, basically, right? So we know 1x is equal to whatever this number is, 1y is equal to whatever this number is, and 1z is equal to whatever this number is. So this is a really powerful command and powerful tool when it comes to solving systems of equations, basically in one step. So we're going to look at a couple problems from today's worksheet. They're real-life scenarios, which of course means they are word problems. So I'm going to talk about the last two items on the worksheet, number 67 about movie tickets, and then number 75 about candy assortments. Let's start with number 67 here. It says, a 275-seat movie theater charges $11.25 admission for adults and $8.50 for children. If the theater is full and $2,860 is collected, how many adults and how many children are in the audience? So there's actually an exact number that we can solve for. Just knowing that the theater was full, all the seats in the theater were full, and exactly how much money was collected, we can figure out exactly how many adults and how many children were in attendance. So for starters, let's identify what x and y are going to represent, right? The two things we're trying to solve for are how many adults and how many children. So why don't we let adults be x, right? So x can be the number of adult tickets. And the other thing we're trying to solve for would be the number of child seats. So let's let y be the number of children tickets. There you go. That's the first skill. What are you going to let x and y represent? Those are the things you're trying to solve for here. The next skill, and probably the most important skill, is being able to write the equations from the word problem. And my hint to you is to look for the totals. Always think about, no matter the scenario, can we identify a total amount and then write an equation from that? So that's my hint when it comes to writing the equations. Look for the totals. For example, how about the total number of seats in the theater? If x represents the number of adult seats and y represents the number of children's seats, and the theater was full that night, then couldn't we just add up all the adult tickets and all the children tickets to get full capacity? In other words, couldn't we just do x plus y, so all the adult tickets plus all the children tickets should equal however many it said the movie theater seats 275 people. So if we add up all the adults and all the children tickets, that should give us the full capacity of 275 seats. All right, so there's our first equation. We're going to need one more. Since we've got two variables here, we're going to need two equations to be able to solve this. Well, the other total we could look for is the total profit, right? It says that night when the movie theater was sold out, they collected $28.60 in profit. So why don't we write an equation for the total profit? So how much money they pulled in. Well, we know for every adult ticket, for every 1x that's sold, they earn $11.25. So why don't I say $11.25 for every adult that was in the theater, and then $8.50 for every Y, right? For every kid ticket that was sold. And if we add up the ticket costs for all the adults and all the children, that should get us to our total amount, which is $28.60. All right, there you have it. There's our two equations. Again, look for the totals, right? You identify X and Y being the things that you want to solve for, and then we write our equations in terms of what we know about the totals from the problem. That's the hard part. Now let's get to the easy part. Put this into an augmented matrix that we can type into our calculator. So this is going to be a 2 by 3. The first row would be 1x plus 1y equals 275. There we go. The second row would be 1125x, 850y, 2860. So we've got our augmented matrix ready to type on our calculator. Remember, you hit second matrix and then go over to edit, and you can type this matrix in. And let's get to reduced row echelon form, RREF. And to do that, once you've typed the matrix into matrix A, you simply hit second matrix, right? It's a little X inverse button. Then just go over to math. There's a lot of matrix math operations you can do. And just scroll down to RREF. And then make sure you select matrix A. And for the full tutorial, again, go watch the video before this, day 4C, for the full calculator tutorial. Anyway, once you run the RREF command, you should get the first row in your matrix to be 1, 0, 190. And the second row to be 0, 1, and 85. There we go. We have our matrix in reduced row echelon form. Ones across the diagonal, there's the zeros. And from this matrix, when we put this back into X, Y, Z form, in this case we just need X and Y, we get X equals 190 and Y equals 85. Now, so many students just stop there and they're happy with that and they circle that. But unfortunately, that doesn't quite answer the question, right? Let's actually answer the question that was asked, was how many adults and how many children are in the audience, right? So put this answer into the context of the problem. That's an important part when you're answering these real-world scenarios. So we can say there's 190 adults, right? That's what X was, and 85 children in the audience. So that's our actual answer here. Make sure you give a sentence and interpret those numbers in the context of the problem. Okay, let's take a look at the final question on this worksheet. The last one we'll do in this video about candy assortments. It says a small candy store makes 3 types of fudge. Crunchy fudge contains 40% caramel and 60% peanuts. Chewy fudge contains 30% peanuts and 70% raisins. Blended fudge consists of 40% caramel, 30% peanuts, and 30% raisins. If the store has 90 pounds of caramel, 99 pounds of peanuts, and 120 raisins or pounds of raisins available, how many pounds of each type of fudge should be made, assuming all the ingredients are used? So again, the first skill is what's going to be X or Y or Z? And if we look, it says how many pounds of each type of fudge. So the types of fudge is what we're solving for. So let's let those be X, Y, and Z. So for starters, how about we let X be crunchy fudge? Sounds delicious. Then Y can be the next one. Y can be the number of pounds of the chewy fudge. And then Z can be the number of pounds of the blended fudge. All right, so we've got our 3 variables, X, Y, and Z, representing the 3 things we wanted to solve for, right? How many pounds of each type of fudge should be made. And so since we have 3 variables, we're going to need 3 solid equations to be able to solve this. And remember, my hint is to look for totals, right? In this case, we can look for totals in terms of their composition of caramel, peanuts, or raisins, right? So for starters, let's look at total caramel. And we'll look at how it's distributed, like what percent goes into the crunchy fudge, what percent goes into the chewy fudge, and what percent goes into the blended fudge. So for caramel, it says 40% goes into the crunchy fudge, so I'm going to put 0.40x, and 40% goes into the blended fudge, so I'm going to put 0.40z. But it didn't mention anything about being in then y. It didn't mention anything about the chewy fudge, right? It just mentioned it was in the crunchy fudge, x, and the blended fudge, z. And we can see that right here. Okay, and we know that in total, this store has 90 pounds of caramel. So 40% of this is caramel, plus 40% of this is caramel. And since they're using all the fudge, this is going to be equal to 90, right? Because it says they had 90 pounds of caramel. All right, that's our first equation. The two types of fudge that had caramel, and it adds up to 90. How about the next ingredient here for peanuts? The crunchy fudge X had 60% peanuts, plus the chewy fudge Y, 30% peanuts, plus 30% peanuts in the blended fudge. And the total number of peanuts that all this has to add up to at the end of the day is 99 pounds. So I'm going to say equals 99. And one more equation, of course, is going to be for the total raisins. And there is no raisins in the first type, in the X, right? The crunchy fudge doesn't have any raisins. But the Y, the chewy fudge, it says 70% raisins for the chewy fudge right there. So I'm going to put 0.70Y. I'm going to leave the X1 blank because there is no raisins in that type. And then 0.30Z, right? Because the blended one is 30% raisins. And then it has to add up to 120 for the total amount of raisins. So there you have it. And one other interesting thing to note here that's unique to this problem, if we look at the percentages, right? I know they're written in decimal form here. Let's say for X, right? The pounds of crunchy fudge. Well, X is composed of 40% caramel and 60% peanuts. What do you know? If you add those together, that gets you to 100%. The same for Y. Y is composed of 30% peanuts, 70% raisins. If you add those together, you get 100%. And the same thing would apply for Z. Since we've got our three equations, let's move forward with our augmented matrix here. So the first row, 0.40, 0 for the Y term, since there was none of that in Y. 0.40 for Z and 90. The second row, 0.60, 0.30, 0.30, and 99. In the third row, we have 0, 0.7, 0.3, and 120. All right, grab your handy-dandy calculator or TI-84 app, and we are going to do reduced row echelon form, RREF, on this matrix. And once you've typed the matrix in and run the command, you should be looking at a matrix like this. 1, 0, 0, 21, there we go. 0, 1, 0, 84. 0, 0, 1, 204 is our matrix in reduced row echelon form. And if I put this back into a system of equations, back into XYZ form, now we know X equals 21, Y equals 84, and Z equals 204. I know we've got those values right now and we're really happy, but we have not actually answered the question that was posed, which was how many pounds of each type of fudge should be made. So let's answer the question in the context that it was asked. And we know these values, right? And we know what they should represent. So for starters, we know that they should make 21 pounds of the crunchy fudge. That's what X represented. 84 pounds of the chewy fudge, which is what Y represented, and 204 pounds of the blended fudge, which is what Z represented. There you have it. There's our answer in context. Wow. RREF matrices make solving these systems of equations so much easier, and then we can answer it in context. All right, that's your preview of how to use RREF with these type of applications, real-world scenarios. That leaves you with a couple word problems left to do on this worksheet, and that's all for this video. Thanks for watching.